you are asked to determine the relative humidity of air in the laboratory by measuring the dew point. You are provided a copper calorimeter with polished outer surface, the thermometer, water, a sufficient amount of small pieces of ice, and a transparent glass plate. An incomplete experimental setup that can be arranged for this purpose is shown in the figure. Part A. In order to perform this experiment, you have to pour water into calorimeter. Out of the three water levels A, B, C shown in figure 1, select the most appropriate level. We have to pour water up to level B. Because of the water level should be more than half of the calorimeter. When getting dew point, we have to use a small ice cube, and we can put ice cubes into calorimeter with water, and we have to find the temperature that dew is creating on the outer surface. When dew is creating, we have to maintain the maximum height of water, because of we can assume that this full surface of calorimeter is at the same temperature. But if we are getting water level as C, we can't put ice cubes without an overflow. Therefore, the best position, the most suitable level is level B. In part B, three thermometers PQR having temperature scale range -10 to 50, -10 to 100, -10 to 200, respectively are available in the laboratory. Select the most appropriate thermometer for this experiment. In this experiment, we are measuring the room temperature and value less than room temperature as the dew point. Therefore, we can use the thermometer with the smallest range, because of when the range is decreasing, accuracy of the thermometer is increasing. Therefore, you have to use appropriate thermometer is -10 degrees to 50 degrees thermometer. We have to write the reason for the selection. We can write the least count of this thermometer is a small value. We know that percentage error is least count divided by reading multiplied by 100%. Therefore, it has a high accuracy. Then part C, what is the other important item necessary to perform this experiment, which is not given. They have not given a styrer. We have to use a styrer to styring system after adding a small ice cube. Then we can write stirrer. When using a stirrer for this experiment, we have to make a stirrer with a mesh. Because of ice is floating in water, we have to maintain ice cubes in immersed condition, immersed situation. Therefore, we can use a stirrer with the mesh. Then part D, in order to determine the dew point, you have to measure two temperatures. Write down the experimental steps that you should follow to measure the first temperature accurately with the observation that you notice. We have to add one piece of ice to the calorimeter with water, and then we can stir well to melt ice in water. And we have to observe, we have to get the temperature corresponding to dew is creating on the outer surface of the calorimeter. We can identify clearly the dew creating temperature by using a tip of a paper, and we can use the tip of paper by paper to get the temperature. We can draw lines in outer surface of the calorimeter. Then we have to write step by step. Part B. First one is put an ice cube to calorimeter with water. Then stir to melt ice. Then third step is get the temperature which the dew is created on calorimeter. We can observe dew in the outer surface of the calorimeter. Then part E. In order to measure the second temperature accurately, write down the experimental steps that would follow with the observation that you notice. When getting second temperature, we have to stop putting ice, and we have to continue stirring. Then we can get the temperature measurement when the dew is vanished. Then we can write stop putting ice and stirring continuously. Measure the temperature. You can observe that dew is vanished. Then part F. Write down a disadvantage of using water at 0 degrees instead of ice pieces to perform this experiment. The heat energy of the system will be absorbed by ice in two methods. First one is to melt ice. Second one is to increase the temperature of water created by melting ice. Therefore, if we are using water in 0 degrees and heat energy will not absorb to melt ice. Therefore, a large amount of water will be required to experiment. Then we can write there is no heat absorption to melt ice. Therefore, a large amount of water in 0 degrees will be required to get the dew point. Then part G, 1. Give two errors that can occur if the transparent glass plate is not used in the experiment. Assume that the face mask and face shield are not used. We know that when doing this experiment, if we are not using a gas shield between our face and calorimeter, the temperature near the calorimeter will be changed due to the respiration and the relative humidity near the calorimeter also changing due to there is no barrier between calorimeter and face. Then we can write first one is temperature near the calorimeter will be changed. Temperature near the calorimeter will be changed. Then second one, water vapor. In exhale, air will be deposit in calorimeter surface, on calorimeter surface. Then part 2, if three gas plates L, M and N with dimensions 5 by 5 centimeters, 20 by 20 centimeters and 80 by 80 centimeters respectively are available, what would be the best gas plate to be used in this experiment? Give reasons for not selecting other two plates. The best plate is 20 by 20 plate. It means plate M. Then we can write G part 2, M plate. If we are using the plate L, dimensions of L plate is 5 into 5 centimeters. It is a small one. Therefore, it can't cover the face because of it is a small one. Then if we are using in plate is 50 by 80 by 80 centimeters, it is approximately about 1 meter. It is a larger one. We can't do the practical because of it is a larger one. We can't put ISO styling. It is difficult to put ice and styling when using this plate. It is a larger one. Therefore, most appropriate plate is M plate. Then part H. In this experiment, the average value of the dew point and laboratory temperature are found to be 26 degrees Celsius and 30 degrees Celsius respectively. Determine the relative humidity of air in the laboratory using the graph given in figure 2. In the graph, x-axis gives the laboratory temperature and y-axis gives the dew point. In figure, straight lines represent different relative densities, relative humidity values, 100%, 90% and 80% relative humidity. We have to obtain, they have given that room temperature is 30 degrees. Then we have to select 30 degrees from x-axis. It is representing room temperature. And dew point is 26. Dew point 26. Then we have to get 26 from y-axis. And we have to get the corresponding graph with 100% relative humidity. 30, 26. Now we have to find the relative humidity, not 100% line. We have to obtain 30 from x-axis and 26 from y-axis, and we have to find the relative humidity graph corresponding to this point. Then we can obtain relative humidity graph corresponding to this point is 80%. Then 80% is the relative humidity of the laboratory.